The second type of general question we're going to have is called chemical composition. And what I've shown you here is a little grid to kind of help you see. There's 3 types of questions the books present. They determine percent composition from formula mass, from molecular formula to percent mass. Then the second type is you derive an empirical formula for percent composition. You start with the percent and you're going to move to empirical formula. That's your second type of question. Okay. And the third type of question is where you go from empirical formula. You'll see why I showed that path back to molecular formula. And we'll work through each of those. Okay. The reason this is put, by the way, in the stoichiometry chapter is you have to do a couple of one-step stoichiometry calculations in here. So that's why it's mixed in with this. But you can actually almost think of it as a totally separate type of problem. So in your next test, you need to have your brain kind of compartmentalized into 3 different types of problems. You're going to do stoichiometry type problems, you're going to do percent composition type problem, and you're going to do molarity type problems. Okay, so here we go. So we're going to work through each of these. Now, also, it's possible, and oftentimes happens, that you can be given that and have to go all the way. In other words, there is a form where we combine what I'm going to call this yellow or B level from this C level. And so let me go ahead and write that in the notes. I normally just refer to these as this is really kind of your type A problem. Yeah, and this yellow is kind of a type B problem. And then this last green area going from empirical formula to molecular formula, that's kind of your type C. Okay, so you'll want to know how to do each of those. So probably on the exam, you'll have questions that just are like just that P, just that segment, just that segment, just this segment. And then you might have one that goes all the way from here over to here. So actually the 4th type is a combination of B plus C. Okay. Right. So what I'm going to do is I'm going to take these. I'm going to show you how to work A type, how to work a B type, how to work a C type. And in the mix, I'll teach you the difference between an empirical formula and a molecular formula. First of all, let's talk about an empirical formula versus a molecular formula. Empirical formula is oftentimes called the simplest formula. So let me give you an example. Let's say you have a molecule and it's made of 5 units, 5 repeating units. And you can think of this as a chain, and each of those repeating units is a chain link. So when you string them all together and you look at that is the molecular formula. So if I look at this chain and I see that all 5 of these links is identical, one link would be called the empirical formula. It's the formula that's repeated over and over to give you your molecule. And we see this a lot. Polyethylene, guess what that is? A bunch of repeating ethylene top units. Yep. Okay, and sometimes there can be millions of these repeating units. So here's the deal that you also need to know about this. A molecular formula has a molecular weight, right? So what is your molecular weight of this material? Well, the molecular weight is just what? The weight of one of these times 5. It's the weight of all of them together. Now, an empirical formula can also have an empirical weight. Well, how do you calculate that? Well, easy. You just add up all the atoms that are in that simple formula. So the empirical weight is just the weight of one of these. Okay, with that as a backdrop, let me show you one more graphic here before we move on. So in my little housetop diagram, and this is something I invented so that I could put all 3 of these types of formulas on the same grid so you could kind of follow along. I kind of like this this flight path thing where you can just kind of follow where you start and where you stop. So anytime I give you some of this information, that's kind of your star, and anywhere you're headed on here is kind of your box, and you're going to use the same type of logic. Okay, right. So what I want to show you right here is the molecular formula. When we talk about molecular formula, we're talking about this chain link thing. When we talk about empirical formula, we're talking about just one of those chain links. The only caveat, the only warning that I need to give you is that sometimes the molecular formula is exactly the same as the empirical formula. In other words, there are no repeating unit. For example, water, H2O. There's not any repeating units there. There's just one. So the empirical formula is H2O, and the empirical weight is 18. And the molecular formula is also H2O. And the molecular weight is also 18. So that's the only place that my chain analogy breaks down. Or to fix that analogy, I'll say a chain can also be one link. I don't think one link makes a chain, but here we go. Okay, so what I want to do is take an example. I'm going to take this material, H2O2. I'm going to work a type A problem where I calculate the weight percents of those, and we'll work through those. Then I'm going to start with these weight percents, and I'm going to show you how to calculate the empirical formula. And then once we have the empirical formula, I'm going to show you how to calculate the molecular formula. So we're going to go all the way around this thing with the same compound so that you can compare and contrast and can see the movements. Okay? And when we get through with it, you can look back at this kind of as a summary slide. And most of the data, memory jogger information is on here. Okay. Right. This is something that comes out of a textbook. I'm going to skip this for now, but when I get through, you're going to be able to see the gram to mole little simple calculations that I referred to. Okay. So what we're going to do after I walk you through this is then we're going to do some calculations with other problems. Right. Okay, so let's start out with H2O2. And this is going to be very difficult with this. Okay, so the first thing we need to do is figure out what the weight percent. Now notice, it's key to understand. When you write a formula, what does this 2 represent? That's what? Moles of material. That's moles. And what did we do? Weight percent, what is that? That's weight. So hopefully you can see the mole. I'm just going to have to speak it. I can't write it. Okay. So what you're going to have to see is the mole to gram. That's that stoichiometry. So what do you use to get from moles of each of these to grams of each of these? You're going to need what? Molar mass. Where do you get it? Periodic chart. And then once we have the grams of these, we're going to do percents, which is what? Part over the whole. So let's do that. H2O2. So let's dissect the formula. What do we have? We have 2 H's and we have 2 O's. Does everybody see this is my formula dissected into pieces? Okay. Now what do I have? I have 2 hydrogens and each one weighs 1 gram. So I have a total of 2 grams of hydrogen in one of these. In one of these I have 2 H's and 2 H's weighs 2 grams. How about oxygen? Well, in my formula I have 2 oxygens, 2 O's, and each oxygen weighs 16 grams. Each mole of oxygen weighs 16 grams, so I have 32 grams of oxygen. So in 1 mole of this material, and anytime you go here, that's the kind of the key. You're going to assume you have one of these. One of these is going to give me a total of 2 of those hydrogens, and 1 peroxide is going to give me 2 oxygens, and there we go. In other words, this is equal to what? 1 H2O2. What is my total weight for 1 mole of peroxide? Well, that's pretty easy. I can just add these 2 together. It's the weight of all my hydrogen plus all my oxygen. And so that winds up being 34. Let me draw that line all the way across. So you can try to treat this almost like a second grade problem. This plus that gives me that. 2 of these plus 2 of these gives me 1 of those. Okay, so I have 34 grams. Fine. I just did the mole, and now I can look at peroxide in terms of what? Weights. So what's my weight percent of hydrogen? Well, that's easy. Percent is part divided over whole times 100. How many parts of hydrogen do I have? 2 parts. How many parts? What's the total parts? 34 parts. 2 divided by 34 times 100 is 5.9. By the way, that should be 2.0 to make this sig figs work out, not 2. Right. Okay. So what's my weight percent oxygen? I've got 32 parts of oxygen, and the whole thing weighs 34. And so I have 94% oxygen. And those sum up to be 100%. Okay, that is your type A problem here.